Structural analysis 2, chapter 8, deflection using energy methods. So we want to calculate an example beam. Last time we solved two simple support beam with distributed load of W, and we already calculated delta maximum with the help of virtual board. This time we want to calculate the angle created at A. Let's approach the problem. So if we want to calculate the theta at A, and due to symmetry, we do theta A is equal to theta at B angle. Both sides are. And if you remember from mechanics of solid by integration method, as soon as you have the equation of moment, and m over ei is d squared y over dx squared, and m is equal to ei times d squared y over dx squared. If you integrate m, it just gives you theta. You just replace that in here. Already know c to calculate constant of c1, and if you just replace in the integration, final gives you theta a is equal to theta bwl cubed over 24. That's the answer by integration methods. You can also solve the problem with the help of moment area theorem, and it says just if you want to calculate a slope, that's the area under m over y. So let's see how that goes. So theta a minus theta c, and you can easily see theta at c is 0, and that's m over e of a to c. That's area. Theta at c is equal to 0, and the area of under m over y over c, that's 2/3 of L over 2/3 of 2 times WL squared over 8EI, and if you do the math, it just gives you WL cubed over 28EI to 4EI, which is the same like integration method. This is solution 2, area method. Going to go a step farther and solve it our third solution, which is from structural analysis, and that's virtual work method. In that case, we are in the part B of previous problem. If you want to review that part, that's the calculation parts A and B. Virtual work, I calculate deflection at C, which is the maximum deflection, also theta at A after deflection. So if you cut the beam through by a of x and a dimension, it just gives you convert distributed load to a concentrated load at the center. Then summation of moment about x goes 0, it just gives you moment equation. As soon as you have the moment equation, like a half of wx minus half of wx squared, as soon as you have that, that was for real moment. For virtual moment, because you want to calculate theta at a, you just need to create virtual moment by the 1 in a and calculate them. So if you do so, then summation of moment, for example, about a goes 0 minus 1, because this is our positive counterclockwise, and our moment is just applied, considered to be clockwise. That's a negative 1 plus RB, reaction at B times the length of the beam from point A, just turns to RB is equal to 1 over L. So as soon as we do know that summation of forces in y direction goes 0, vertical direction, it just says this is upward, it should be downward, and that's equal to the same new value but in negative direction. So RA is downward. As soon as we have RA, we can write our equation, small equation m virtual moment. That's summation of moment. X goes 0, it just gives us mx plus 1 over L times x minus 1, which is this virtual moment, 0, and it just gives us mx is equal to 1 minus x over L. As soon as you have this equation, you can simply apply the equation of virtual work, this time 1 times theta at A. That's m times capital M integration over ei x. And for small m, you replace the virtual moment. For capital M, you replace the actual moment, multiply them by each other, and integrate it from 0 to L to get the theta at A. If you do so, and you get this equation, and if you solve that equation, solve this integration. If you do the math, it just use the limitation of the integration is from 0 to L. It just gives you a value which is summation of this times WL cubed over I, and that's 1 over 24 WL cubed over EI. That's 1 over 24 WL cubed over EI. Which if you compare the result of virtual work in terms of theta at A, which is also equal to theta at B, symmetry, and if you just compare it with the previous two solutions, which I will provide link forward that to see if you're interested to see how integration answer and also moment area get the theta at B are already a little bit of them, and it just gives us solution 1, solution 2, and solution 3, which is from structural policies, mechanics of materials, gives us solutions 1 and 2, which is the integration, and also more area method, and last one, which is theta A, comes from solution of structural part analysis with the help of virtual work. We'll solve more problems in virtual work approach in themes and frames in next videos. Thank you.